Hi everyone, welcome back. Today we're solving minimum penalty for a shop. So in this problem, we'll be given a string containing of y and n's. And if the character is y, it means there will be a customer coming at that hour. If it's an n, it means no customer will come at that hour. And our goal is to find somewhere within the string where we can close the shop. And we want to have minimum penalty. So there will be a penalty if we close the shop and a customer come, or if the shop is open and no customers come. And if there's a tie between two different times that we can close the shop, then we will choose the earliest hour between the two times. So if we look at this example, the best time would be to close it here, because if we close it here, the only penalty would be right here where the store is closed but a customer came. And the other time that we can close it is if we can close at the very end, which means this is the only penalty we get. But between closing here versus closing here, this is earlier, so we return 2 as our result. So it's best to close it after 2 hours. And if we look at this example, it's best to close it before everything started, since no customers are going to come either way. And for this example, it's obviously best to close at the very end, which is after 4 hours, because there will be a customer come in each of these hours. So now that we have seen some examples, let's get to how we can solve this problem. So to solve this problem linearly, we can look at these lines as the border of when we will close the shop. So everything to the left of the line is closed and everything to the right of it is open. And we will just initialize the current as if there are 0 penalties. So initially, we will always put the wall to the front and we will iterate through. And as we put the wall in certain places one by one, for example, we see that it will be right to close it here instead of here because someone does come here, so it will be better to come here. Then for this example, that means there will be 1 less error, so we will decrement this by 1, so it will become -1. And if we see that this is less than minimum, then we need to update the result as certain index, and we have to update the minimum to current and then continue this algorithm until we come to the end of the array. And then we can return our result. So let's go over this example real quick. So first, since this is open, it's better to close it here. So we decrement this by 1 and we will update the result to closing after 1 hour, and we have to update minimum to current. Now we go to the next one, same thing. We see that it is also better to close it later, so we decrement by 1 again, update result and update minimum. Now we go to the next one. We see that this is wrong. It is better to close it here, since no one came later, so you might as well close it here. So that's why we increment current by 1. And then we come to the last one. We see that it's the right move to close it later, so we increment current back to -2. It is equal to -2, but we don't update result because remember, we always return the earlier date if there's a tie. So now we can return 2 as our result. And the time complexity would be O of n, where n is the number of characters in customers array because it will take linear time to iterate through. And the space complexity would be O of 1, because the space that these variables take up do not depend on the size of the input. So now let's get to the coding part. So first we will initialize minimum, current, and result all to 0. And now we will look through customers. So for I in range, the length of customers, if it is a yes, then we will decrement by 1. Because that means there's 1 less error if we move it over. Otherwise, if it's a no, then we increase by 1, because that means there's 1 extra error. And if current is less than minimum, we will update the result. So result equals I plus 1, and we will set the minimum to current. And then we can return result at the end. See if it works. Okay, perfect. Hope this was helpful. Thank you for watching. If you have any other questions or comments, feel free to leave them in the comment section, and I hope to see you all again soon.